The Sun is the star at the center of our solar system. It is a massive, glowing ball of gas that provides light and heat to the planets orbiting around it. But have you ever wondered what the Sun is made of and how it produces its energy? In this video, we will explore the chemistry of the Sun and learn about the processes that power it. The Sun is composed mainly of hydrogen and helium, with trace amounts of other elements. In fact, about 70% of its mass is hydrogen, while helium makes up about 28%. The remaining 2% is made up of heavier elements such as carbon, nitrogen, and oxygen. The Sun's energy is produced through a process called nuclear fusion. This process occurs in the Sun's core, where the temperature and pressure are so high that hydrogen atoms are forced together to form helium. This reaction releases a tremendous amount of energy in the form of light and heat. But how does nuclear fusion work? Well, it all starts with the hydrogen atoms. Hydrogen atoms have a single proton in the nucleus, which is positively charged. When two hydrogen atoms come together, the nuclei are forced close enough to each other that they can fuse together. This fusion process creates a new nucleus with two protons and two neutrons, which is the nucleus of a helium atom. However, in order for fusion to occur, the hydrogen atoms must be heated to incredibly high temperatures and pressures. In the Sun's core, the temperature is about 15 million degrees Celsius, and the pressure is about 250 billion times the atmospheric pressure on Earth. These extreme conditions allow the hydrogen atoms to overcome their natural repulsion and fuse together to form helium. The energy released during nuclear fusion is what powers the Sun and allows it to shine. But this process is not without its consequences. As the Sun fuses hydrogen into helium, it gradually loses mass. Over time, this will cause the Sun to expand and eventually become a red giant, engulfing the inner planets in its outer layers. In the next segment, we will explore the different layers of the Sun and how they contribute to its overall structure and function. The Sun is not a solid object, but rather a ball of gas. It is composed of several layers, each with its own unique properties and functions. The outermost layer of the Sun is the corona. This is the Sun's atmosphere, which extends millions of kilometers into space. The corona is extremely hot, with temperatures reaching up to 2 million degrees Celsius. However, despite its high temperature, the corona is not very dense, and its particles are constantly escaping into space. Beneath the corona is the chromosphere. This layer is much cooler than the corona, with temperatures ranging from 4,000 to 50,000 degrees Celsius. The chromosphere is visible during a total solar eclipse as a thin red ring around the Sun. This is also the layer where solar flares and prominences occur. The photosphere is the layer of the Sun that we see when we look at it. It is the Sun's visible surface, and it has a temperature of about 5,500 degrees Celsius. The photosphere is not a solid surface, but rather a layer of gas that is constantly boiling and churning. This is what causes the Sun's surface to appear granulated. Beneath the photosphere is the convective zone. This layer is where the energy produced by nuclear fusion in the core is transported to the surface. The convective zone is characterized by the movement of hot gas rising and cool gas sinking. This creates a pattern of convection cells that can be seen on the surface of the Sun. Finally, at the very center of the Sun is the core. This is where nuclear fusion occurs, and it is the source of the Sun's energy. The core is the hottest and densest part of the Sun, with temperatures reaching up to 15 million degrees Celsius and pressures that are 250 billion times greater than the atmospheric pressure on Earth. Each layer of the Sun plays a crucial role in its overall structure and function. Understanding these layers is essential to understanding the chemistry of the Sun and how it produces its energy. In the next segment, we will explore the Sun's magnetic field and how it affects the Earth. The Sun has a powerful magnetic field that extends throughout the solar system. This magnetic field is created by the movement of charged particles within the Sun's interior. As these particles move, they generate electric currents, which in turn create a magnetic field. The Sun's magnetic field is not static, but rather it is constantly changing and evolving. This is due to the fact that the Sun is not a solid object, but rather a ball of gas that is constantly moving and churning. As a result, the magnetic field of the Sun is highly dynamic, with regions of intense magnetic activity and regions of relative calm. One of the most visible manifestations of the Sun's magnetic field is the presence of sunspots. Sunspots are dark, cooler regions on the surface of the Sun that are caused by intense magnetic activity. They are often accompanied by solar flares and coronal mass ejections, which can have a significant impact on the Earth. When the Sun releases a coronal mass ejection, it sends a burst of charged particles hurtling towards the Earth. These particles can interact with the Earth's magnetic field, causing geomagnetic storms and auroras. In extreme cases, these storms can disrupt power grids, satellite communications, and other technological systems. The Sun's magnetic field also plays a role in the formation of the solar wind. The solar wind is a stream of charged particles that flows out from the Sun in all directions. This wind is responsible for creating the heliosphere, which is the region of space dominated by the Sun's magnetic field. Understanding the Sun's magnetic field is essential to understanding the chemistry of the Sun and its effects on the Earth. By studying the Sun's magnetic activity, scientists can better predict and prepare for the impact of solar storms and other space weather events. In the final segment, we will explore the future of the Sun and what it means for the future of our solar system.